Our goal in problem 1 is to find the antiderivative of the function, minus 3x squared, plus 10x times cosine of 7x. Our aim in this problem is to find the antiderivative of the function, minus 3x squared, plus 10x times cosine of 7x. Let us integrate the function, minus 3x squared, plus 10x times cosine of 7x. We know that, at first glance we easily see that the function we have to integrate is a product of a nonlinear function, cosine of 7x, with a polynomial function, minus 3x squared, plus 10x. Occasionally, when you are faced with this type of complex integration problem, you have to adopt the appropriate strategy that will help you simplify the problem, and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2, for solving integrals that involve the products or quotients of nonlinear functions are the U substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. Remark that, the polynomial function, minus 3x squared, plus 10x is of degree 2. In sum, our first goal will be to reduce the degree of the polynomial function to 1, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v, minus the integral of v du. Consequently, we set u equal to minus 3x squared, plus 10x, so du equals minus 6x, plus 10 dx. And, dv equals to cosine of 7x dx, and v equals to 1 over 7 times sine of 7x. Finally, the integral of minus 3x squared, plus 10x times cosine of 7x dx is equal to minus 3x squared, plus 10x over 7 times sine of 7x, plus the integral of 6x, minus 10 over 7 times sine of 7x dx. Consequently we still have to integrate 6x, minus 10 over 7 times sine of 7x, using integration by parts. Let us integrate the function 6x, minus 10 over 7 times sine of 7x. Given that the function to integrate 6x, minus 10 over 7 times sine of 7x is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function 6x, minus 10 over 7. Thus, we set u equal to 6x, minus 10 over 7, so du equals 6 over 7 dx. And, dv equals to sine of 7x dx, and v equals to minus 1 over 7 times cosine of 7x. In sum, the integral of 6x, minus 10 over 7 times sine of 7x dx is equal to minus 6x, plus 10 over 49 times cosine of 7x, plus 6 over 7 over 49 times sine of 7x, plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of minus 3x squared, plus 10x times cosine of 7x. The first integration by parts gave the following result. So, the integral of minus 3x squared, plus 10x times cosine of 7x dx is equal to minus 3x square, plus 10x over 7 times sine of 7x, plus the integral of 6 over 7 times cosine of 7x dx. From the second integration by parts, we obtain the following result. So, the integral of 6 over 7 times cosine of 7x dx is equal to minus 6x, plus 10 over 49 times cosine of 7x, plus 6 over 49 times sine of 7x plus a constant of integration c. Finally, combining the last two results, we see that the integral of minus 3x square plus 10x times cosine of 7x dx is equal to minus 3x square plus 10x over 7 times sine of 7x plus minus 6x plus 10 over 49 times cosine of 7x plus 6 over 49 times sine of 7x plus a constant of integration c.